Welcome to your algebra recording for the week of May 2nd. We are officially in the last month of the school year, so that is exciting. And we're actually in week 16. That should say week 16, not 15. We are in week 16, and I do have a warm-up question for us to start with. So I'd like for you to get your math notebook out, and we're going to start by graphing a linear equation. So the linear equation that I have is y equals negative 2/3 x plus 5. And I just want you to graph that equation on a coordinate plane in your math notebook. So go ahead and click pause and graph that on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so to graph lines, we always start by plotting the y-intercept. And what is the y-intercept in this equation? So remember, that's where we cross our y-axis. The y-intercept is where we cross the y-axis. And it's always our constant term, the term that is not being multiplied by x. So in this case, our y-intercept is going to be at 5. So I'm going to go ahead and plot that point on the y-intercept in the y-axis. And then we're going to apply the slope. And what is the slope? The slope, remember, is always your m term when you think of it as y equals mx plus b. Our m is always our slope. So the slope, in this case, is the number being multiplied by the x, and in this case it's negative 2/3. So that tells me I'm going to go from my y-intercept, I'm going to go down 2 points and to the right 3. 1, 2, 3. And I'm going to plot that point. Then I'm going to apply the slope again. Down 2 and to the right 3. You always want to have at least 3 points before you graph your line. So then I'm going to go ahead, and since this is just y equals, it's just a linear equation, so it doesn't need to be dashed, it's just a line. And that is our line. So I'm going to move on to the next slide, so if you need more time, go ahead and click pause. All right, so this week we're wrapping up our unit on linear applications. So we're going to wrap up our unit on linear applications, where we looked at graphing, we graphed inequalities, we solved systems of equations. We learned 3 ways. We can either solve a system of equations by graphing, by using the combination method, or using substitution. And then we looked at how we can also graph inequalities and how we can determine if a point is included in an inequality. So we're going to wrap up the unit. There's a cell phone plans where you guys are going to look at a real world application, little project, a mini project if you will, and then you're going to take the unit test. You're going to review and take the unit test. And that's it for this week. Just a heads up, we are about 3 weeks away from the last day of school. So I'm going to keep reminding you of this so that you're aware of where you are now and where you want to finish the school year, and keeping in mind that you only have 3 weeks to do so. So now is the time to start focusing on reaching your goals. All right, so this week you're going to be looking at a real-world application with cell phone plans, and I'm gonna go over a real-world application using a trip to the amusement park. So this is gonna be very similar to what you see with the assignment you have to do this week with the cell phone plans. So taking notes on this is gonna be very, very helpful in helping you complete the cell phone plan assignment this week. So make sure you're taking good notes because it's going to be very, very similar. All right, so what is this application? We are going to take a look at 2 deals at an amusement park. So the Fun Time Amusement Park has two deals that they offer in terms of how much you're going to pay for your trips to the amusement park. And you're going to look at it and see what is the better deal given the certain circumstances. So the first deal is a silver pass. And the silver pass, it will cost you $60 for the pass. So $60 for the pass, but it lets you visit the park for only $10 a day. So what that means is you would pay $60 to get you this pass, and then once you have the pass, each time you go to the amusement park, you would pay $10 to get in. The second deal is a pass that costs you $120. So up front, you're going to pay $120 for the pass, which is a little bit more than the silver pass, but then you're only paying $5 every day you go into the park. So we want to determine which is the better deal dependent on how many times you're going to visit the park, because there's going to be different advantages for each pass depending on how many times you plan on visiting the park each summer. So first of all, we want to define some variables because we're going to set up some equations. So based on what we're told, we want to figure out the cost. So we would say let's let C equal the cost. And then what else might affect the cost, the overall cost? The number of days that we plan on visiting the park. So I'm going to let N represent the number of days that we plan on visiting the park. So those are our two variables. The cost is dependent upon the number of days that we visit the park. So those are going to be our two variables that we're going to use. So now we're going to start writing equations to represent the cost of the different passes. So let's start with the silver cost. The silver pass, the cost of the silver pass. So the cost is going to be equal to, well, we have to pay $60 no matter what, and then we're going to pay $10 for each day. So 10 times the number of days will let us know then how much it would cost over the course of the summer. So I guess I could add that C is going to represent the cost over the course of the summer. So now go ahead and write, not equations, I want you to try and come up with the equation to represent the cost of the gold pass. And you can use the equation that we did for the cost of the silver pass to help you get started. So go ahead and click pause, and I want you to try on your own to find the equation that represents the cost of the gold pass. So click pause and try that on your own, and then when you're ready to check your work with mine, go ahead and click play. So in this case, the cost is going to be equal to, well, you have to pay a flat $120 for the gold pass, and then on top of that, it's going to be $5 per day. So 5 times the number of days that you go will let us know what that final cost would be. And add that to 120, and then we'll get our cost for the summer. So there's our two equations. We've got 60 plus 10n and 120 plus 5n. Those are our two equations. So I'm going to go on to the next slide because we're going to answer some more questions. So now that we've got our equations, our two equations, we've got the silver pass, which is C equals 60 plus 10n. And then we've got the equation for our gold pass, which is 120 plus 5n. And my first question to you is, after how many days will the cost of the passes be the same? There is a point in the summer, after a certain number of days, that the cost would be the same for each pass. So how can we figure that out? Well, we can figure that out by graphing and looking where our equations intersect. So let's go ahead and graph our equations. So I'm going to have my x-axis represent the number of days, and my y-axis represent the initial cost. I meant to say our overall cost will be our y-axis. So in order to graph, we know that we always want to, let's go ahead and I'm going to graph the silver one first. The silver one is C equals 60 plus 10n. And in this case, our y-intercept is at 60. So we need our y-axis, the scale, to include 60. And if we look at our second equation, our y-intercept is going to be 120. So we need to make sure that we're using a scale that gets us to 120 at least. So I'm thinking maybe if I go by 20s, 20, 40, 60, 80, 100. Yeah, let's go by 20s. So each tick will be 20. So 2, 4, I'm going to label every other one so it doesn't get too crowded looking. Whoops, that should be 80. 2, 4, 6, 8, 9, 100, 120, 140, 160, 180, 190, 200, 220, 240, 260, 280, and the last, let me see, 2, 4, 6, 8, 2, 4, 6, 8. Whoops, I messed up there. Hold on a sec. Let me fix this scale. All right, I fixed the scale, and then the days, I'm going to go by a scale of how about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. So each tick will just be 1 day. All right, so let's go ahead and plot that first pass, the silver pass, we'll go ahead and do in purple. So the first thing we want to plot is the y-intercept, which is at 60, and then our slope is 10 over 1. So we're going to go up 10 units, so halfway, and to the right 1. So up 10 units, up 1. To the right, so to the, oops, so let me say that again. Up 10 to the right 1, up 10 to the right 1, up 10 to the right 1. We're going to keep doing that because that's our slope. Up 10 to the right 1. So remember, our scale, I did it by 20. So each tick goes up 20. So if our scale or our slope is up 10, we need to go halfway up each time into the right 1. And then once we have enough points, we can go ahead and draw in our line. I'm going to do this in purple. Whoops, hold on a sec. Let me fix that. I was not going to the right 1. I don't know what I was thinking there. Let me erase that. So again, our slope, we're going to go up 10 and to the right 1. So we're going to go over a full. Up halfway into the right 1. Up halfway into the right 1. There we go. Half up way into the right 1. I was kind of getting stuck on the halfways. So up halfway into the right 1. Then we can connect our points as straight as we can make it. And then we're going to graph the gold pass. And let's do that in green. Let's do that, or blue. How about a different color? So the gold pass, we'll plot those in blue. So the gold pass, the equation was C equals 120 plus 5n. Our y-intercept is, y-intercept is equal to 120. And our slope in this case is going to be 5 over 1. So first plot at 120, right there. And then our slope is up 5, so about a fourth of the way up and to the right one. So a fourth of the way up and to the right one. So in this case, it's a little bit tougher with the scale being as large as it is. So if you can make your Y scale smaller, you're going to have an easier time graphing this. And then we're going to connect our points the best we can. And there we go. And now where the points intersect, that's going to be where our plans have the same cost. So let's find where our lines intersect. It's right here. So after, if we go down, we see after 12 days, we're going to be paying the same price. So after how many days will the cost of the price passes be the same? The answer is going to be 12 days. The answer is going to be 12 days because that's where our lines intersect when we graph them. Now another way we could solve that same question would be to just use substitution, and we would set our two equations equal to one another to make sure we did our work correctly on the graph. So another way we could do this is just set the two equations equal to one another using substitution. So 60 plus 10n, set it equal to 120 plus 5n, and we could solve that out. And if we did that, we would find n equals 12. And they're going to be, after 12 days, it looks like the price will be about, it should be 120. So that is another way that you could do this. But on your assignment this week, you will have to graph. And to find out when the deals are the same, it's going to be when your lines intersect. So now that we've got the graph, it's going to be helpful for answering our next two questions. The next question says, if you plan on visiting the park 10 times during the summer, what is the better pass to buy? So let's go to 10 days and we go up, and what's the cheaper cost? Well, at 10 days, it lies, the line that's further down on our y-axis is that purple line. So it looks like if we go to day 10 and we go up, that we hit the purple line first. The purple line was the silver pass. So after 10 days, it's going to be cheaper. If we plan on visiting the park only 10 times, it's going to be cheaper to buy the silver pass. So you can see how graphing both those lines on the same coordinate plane makes it easy to determine which is the better deal. And then it says determine when it's beneficial to buy the gold pass based on the number of visits. Well, let's look at our two graphs right here. We know that after 12 days, we're going to pay the same amount. But then if we look to the right, we see that the blue line, which represents the gold pass, is beneath the purple line, which, remember, if we go over to our y-axis, the y-axis represents the overall price that we're going to pay. So we want to pay the smaller price, right? The least of the two. So that means to the right of 12, we can see that the blue line, which represents the gold pass, is below the purple line. So that means it's going to be more beneficial to buy the gold pass when we spend, or when we plan on spending any more than 12 days at the amusement park. So when we plan on spending more than 12 days, then it's going to be more beneficial to buy the gold pass. So this is exactly what you're going to be doing with the cell phone deals. Is you're going to be given two scenarios, two deals. You're going to set up two equations based on defining some variables. You'll write an equation for each cell phone plan. Then you're going to plot the 2 points and answer some questions based on your two equations. That's a wrap, so let me put up your key phrase assignment. Alrighty, so this week in the recording we looked at how we can graph two equations on the same coordinate plane. And in our case, we graphed 2 deals to the amusement park. And one of the questions I asked you was determine when the cost of each deal to the amusement park is going to be the same. So my question to you is, when you graph 2 lines on the same coordinate plane, how do you identify when the equations are equal to one another? So when the x and y variable, or whatever variables you chose, in our case, the example was that when the number of days and the cost of each deal was the same. So where do you look for, or what do you look for to identify that point? So where does that occur on the graph when you've got 2 graphs plotted on the same coordinate plane? So again, my example that we used was a trip to the amusement park, and we were trying to determine when the cost of the passes were the same. And how did we find that? How did we determine when the cost was the same? So then overall, take that idea, and when you graph 2 lines on the same coordinate plane, I explain how to identify when the equations are equal. So where does that occur on the graph? And that's it. So reminders of how to complete the key phrase assignment are below. If you need any help or have any questions, let me know.